Hey everyone, welcome back to the lab. In this video, we are going to be diving into F# versus TypeScript performance with respect to sorting. All right, so why are we doing this? Well, I did a few recent performance investigations. First, I looked at TypeScript sorting 40,000 elements, and then I decided to port that benchmark and test over to sorting 1,000,000 elements in F#. And so now I have all this like raw data, and I thought we might as well just go and compare them and then see what the results are. So that's what we're going to do in this video. And the question we're trying to ask is, how does performance compare? We need to have a domain to compare them in, so we're just going to choose sorting because that's where I have data in. And we're going to try to compare this over a few different dimensions. We're going to do different data sizes and different data types because, as we'll see, that actually matters quite a bit. So the overall executive summary of this is that F# sorts faster than TypeScript in most cases, but it's actually pretty notable when it doesn't. And so this is kind of as expected. F# is theoretically compiled and run with .NET, so theoretically it should be faster than TypeScript's Node in basically all cases by probably an order of 2 to 10x, and I would actually probably expect closer to like 4 or 5 to 10x in most cases. And if you look at like a lot of workload benchmarks, this is kind of what you would expect. And we see that in some cases, but not all of them, which is kind of fascinating. So for numbers, just primitive numbers, over collections, F# is going to beat TypeScript by about 96%. So that's around our 10x result that we would kind of expect. But for sorting primitive strings, TypeScript actually beats out F# by about 11%, which is, surprising that it can even keep up, and even more surprising that F# is losing. So probably something to look into there, and we will do that a little bit later. The next is sorting objects by number property. F# is faster by about 50%, so our 2x, and then objects by string property, F# is again faster by about 35%, which gives us about that 1.5 to 2x that we might expect. So in general, F# sorting faster, but maybe not as fast as we'd expect, and in some cases, TypeScript still wins. So in the rest of this video, what I'm going to do is dive into kind of how we got these numbers. So first, the benchmark setup, so you can kind of understand what asterisks are involved, so you can kind of understand the pros and cons trade-offs of a benchmark like this, and also figure out how to run it yourself. Next, we're going to go into the detailed results, so all the raw data from TypeScript, all the raw data of F#, and then how they actually compare over the different kind of data sizes and data types, and then I'll leave you off with some next steps to go from here. All right, so first, the benchmark setup. So all benchmarks have asterisks, and here I'm going to show you kind of the ones for this. Basically, the code here for the benchmark is naive, hand-rolled. I kind of wanted to write something myself that had basically no dependencies outside of the language and standard library to make it really easy to copy and paste and run it wherever. These benchmarks go over 200 iterations, trying to run these workloads one after the other to hopefully get a decent end to compare, but also not like take hours to run. I've already done deep dives into each of these, so if you want to learn more about the benchmarks for TypeScript and F#, you can look at those videos. Now, the other asterisk that's usually in a lot of benchmarks is the actual hardware, because if you run it on different hardware, you should probably expect different results. Here, we're trying to make this as deterministic and reproducible as possible with respect to hardware by just using the Replit free instance. You can get this with just a free account on Replit, and it just gives you half of a vCPU and 512 megabytes of RAM. Does this really mean anything? Not really. You can't really compare this probably with a runtime with similar features on like AWS or Google Cloud, because they're all going to have their own like little quirks. But theoretically, one Replit free instance versus another Replit free instance should be more or less the same. All right, so now let's go into the detailed results. So here I've just put all the data from my test runs into a Google Sheet, so it looks nice, and then just copied it here. So if you need to go and refer to this, you can come back to this page. This is the sorting performance for TypeScript using P90 milliseconds. I didn't want to use average because that can get biased. I didn't want to use P50 because that means that 50% of the results are much slower. So I really wanted to go for P90 to give us kind of an upper bound of what you might expect if you actually did this in your own server and like a request kind of environment. How much would that like actually take? And so we can see that up to 40,000, TypeScript is doing quite well within 300 milliseconds, and even for some of these workloads, the strings, the object number property and object string property, it's still within 300 milliseconds. But it really starts to fall off here around the 100,000 and million range, where it's getting up to about a second, and then in the millions, like several seconds. So definitely not something you'd want to do probably in a request context, and even if an async workload, this is pretty slow. What's interesting about TypeScript is that the numbers sort is like extremely slow, even slower than strings by quite a large margin. I don't know why this is. I called this out in the original benchmark, but this is something we'll see as we go forward in the comparison. All right, and here's the F# sorting sorting performance, again, we're using P90 milliseconds here. And we can see that even through 100,000, it's performing very well within 300 milliseconds. And then even up to 1,000,000, yeah, we are in several seconds, but it's low several seconds. And then numbers actually sorts very well, where even through 1,000,000, we're in that, 300-ish milliseconds range. So overall, it looks like F# is doing pretty good. It doesn't have any of those like huge 13-second fall offs or anything like that. But I think this becomes a lot easier to see in comparison. And so here I've compared F# versus TypeScript performance. What we're doing is we're comparing the percent, how much faster F# is versus TypeScript in terms of P90. And I've tried to color code this to make it a little bit more readable, because this is like a lot of numbers on the page. So green is where F# is faster, where it's got like a positive percent faster, and you can think of these as percent fasters here. White means it's about the same. I figured that we're running 200 iterations, but if it's within 10%, that, probably are margin bound of error. So within 10%, I'm kind of just saying it's about the same. And then red means that F# is slower, so TypeScript is actually faster in this case by some percent. So here I would probably just discount all of these within 1,000, because we only had like 1 or 2 or 3 milliseconds, so comparing them is going to give us like weird numbers. But anything 10,000 and up, I think, is relatively reasonable for us to compare this way. And we can see that for sorting numbers, F# is much faster. Again, this is like that 95%, kind of 10x faster look, which makes sense because TypeScript seems to have some performance problems here, and F# really kind of gracefully handled all the way through 1,000,000. For strings, this is the interesting part where TypeScript is, at least the same fast, but often 10 to 40% faster, which is like very surprising, because, theoretically F# should be faster in all of these kinds of benchmarks, but it's just not. But even through these other workloads, F# is still, 20 to 50-ish% faster, depending on the size, the data type, etc. If you want to look at these numbers, again, you can check out the blog post I have linked below, and it has all of these little tables for you to copy, paste, and use however you want. And that's it. So next steps for this, I'd say that there's still some areas of further exploration. First one is like, why is TypeScript's number sort so slow? That's the one area where F# is about 10x faster, but I still think TypeScript, either my benchmark is weird, or TypeScript has like a really weird number sort thing that's slower than strings, which just doesn't really make sense to me. And this next one is trying to figure out, why is F# string sort so slow versus, why is TypeScript string sort so fast? One of these is like way different than I would have expected, and I don't know which one it is. Maybe like tag fast F# or something to dig into this, because I don't really know these like low-level internals that well. But I think these are the two areas that I'm really curious about, that kind of broke my expectations for this benchmark. If you're into performance, and especially F# performance, you might be interested in this video, where I dive into some of the benchmarks for F# Giraffe, find some issues there, and improve it by 6.5x. Linked here and also in the description. And that's it for this video. Thanks for watching. I'll see you in the next.